All right, let's crush another Mtel question. This one says, use the table below to answer the question that follows. So we've got a list of volumes and a list of pressures, and it says the table shows the relationship between the volume in cubic centimeters of a particular gas and its pressure in pounds per square inch at a constant temperature. The relationship between volume and pressure can be best defined as exponential, inversely proportional, linear, or quadratic. All right, so I think the simplest one to understand of these answers is a linear relationship. A linear relationship happens when if the change in your x value is always the same, then the change in your y value should also always be the same. So let's analyze how these variables are changing. So typically, the variable on the top is going to be your x value. That's your independent variable. So one thing depends on the other one. In this case, it doesn't matter too much, I don't think. If volume changes, pressure changes. If pressure changes, volume changes. So they sort of both depend on each other. So that's not super important for this question. But let's analyze what's happening to each variable. So looks like we've got a change of 5 here from 20 to 25. I'm just subtracting 20 from 25. And then change of 5 here, subtracting 25 from 30. Change of 6, which is a little weird. Change of 4, and then a change of 5. So we've got a few places where the change isn't the same. But we can kind of analyze what's happening with the other variable and see what's going on. So that was going up the whole time. It looks like these values are going down, which is interesting. It goes from 180 to 144. That's a change of 36 in the negative direction. So that's a negative 36. And then we've got negative 24 between 144 and 120. Negative 20 here. Negative 10 and then negative 10 again. All right, so there is this like weird 6-4 thing happening up here, but this is definitely not a constant change. We have two negative 10s, but the negative 36 is a considerably larger change than the negative 10, so it's definitely not linear. There's not the same change happening every time. In an exponential relationship, it'll consistently get larger or smaller depending on whether it's exponential decay or exponential growth. So it looks like it could be exponential. Quadratic is when you have a constant change in one of your variables and the second degree is the same each time. So we would take the difference between these values one more time. So now the difference between negative 36 and negative 24 is negative 12. This is negative 4. This is negative 10. And this is 0. So there really isn't a relationship there at all. And even though these aren't completely constant, it's definitely not quadratic because there's not a consistent theme happening here. So I talked a little bit about an exponential equation and the relationships between the numbers there. It looks like it maybe could be exponential. It's a little weird. It's a little funky. But let's talk about what inversely proportional means. The definition of inversely proportional is that the variables always multiply to the same value. So kind of completely different from the differences that we've been taking for the rest of these explanations. We're just going to multiply your two variables together and see what that equals. So 20 times 180 is 3,600. And then 25 times 144 is also 3,600. 30 times 120 is 3,600. 36 times 100 is 3,600. So when you get that relationship, that means that the variables are inversely proportional, and that's exactly what we have here.